This is our first recitation, and today we will talk about Coulomb's law and principle of superposition. According to Coulomb's law, the magnitude of force between two charged particles is equal to constant k that depends on the unit system, and then magnitude of charge 1, magnitude of charge 2, divided by distance between them squared, and this force is along the line between these two charges. And there is also principle of superposition that tells you that if you have several charges, then, for example, you have, let's say, Q1, Q2, Q3, right here, and then you're looking for the force applied on the charge Q0. Then you have to add forces Q1, force exerted by Q1 on Q0, F1, force exerted by Q2 on Q0, let's say all charges are positive, so the force is a repulsive force, and then Q3, F3. So you have to add all these forces as vectors, and you find magnitude of each force. For example, force exerted by Q1 on Q0, ignoring all other charges. So no Q2, Q3, you find magnitude of F1, and the same for F2 and F3, and then you add them as vectors. So our first problem that we will solve today will have three charges. We will use principle of superposition, and we will use Coulomb's law. The first problem that we will solve will have two charges, Q1 and Q2. This is Q1, and this is Q2. Both charges are positive. Both are located at the same distance a from the origin. And we want to find the force exerted by these two charges on charge Q0, that is distance h along y. So what is the force exerted on Q0 by Q1 and Q2? We will use Coulomb's law, and we will use principle of superposition, which means that we will find force exerted by Q1, force exerted by Q2 on Q0, and then we will add these forces as vectors. Since we are interested in force exerted on Q0, I will draw these forces, I will draw these vectors. So force exerted by Q1 will be along this line. This is my F1. Force exerted by Q2 will be along the line connecting these two charges, and this will be my F2, F1 and F2, and I will use unit vectors. So what we need to do now, we need to express F1 and F2 in terms of components, because we need to add them as vectors. And I will use these notations. Unit vector along x, I will call it Ix, and unit vector along y, I call it Iy. So we know that any vector can be written in terms of components. So f Q0 could be written as fx Ix, where fx is x component of f Q0, plus fy Iy, and f1 can be written as f1x Ix plus f1y Iy. And the same for f2. f2 as any vector could be written in terms of components, f2x Ix plus f2y Iy. So what does it mean that we find the vector sum fq0? Fq0 is equal to vector sum of f1 plus f2. So how to find vector sum of f1 plus f2? Fq0, f1 plus f2, we need to add x components of the resultant, f1x plus f2x, and this will be my x component of the resultant. I do not forget to put ix here. And then I add y components. So it will be f1y plus f2y, and this will be iy. This is y component of the resultant. So all we need to do now, we need to find f1x, f2x, f1y, and f2y. Let's start. So I will draw the line, this line which is parallel to x, and I project f1. I need right triangle. So I draw this line perpendicular to x. This is my right triangle, and this is x component of f1. I need to introduce angle. I will introduce this angle. Let's call it theta. Well, we understand that this angle theta is equal to this angle, which is now also theta. And this angle is equal to this angle. Good to know, because this is A and this is A. Okay, so this is x component of f1. First question, positive or negative? It's positive. It is along positive x direction. So I will write f1 is equal to f1x. Should I write it here? Well, let's move here. So what is f1 as a vector? It is magnitude of f1 that I can find from Coulomb's law. It will be k. Now product of q1, q naught. Remember that I put magnitudes here. We already found the direction. We draw this diagram. We know that x component is positive. q1, q naught divided by distance between these two charges. This is the distance. The distance I will find from this triangle. This is hypotenuse, and this hypotenuse r, let's call it r. R squared is equal to a squared plus h squared. So I divide by distance squared, a squared plus h squared. And this is magnitude. I need x component, so I multiply by cosine theta, cosine of adjacent angle. I don't forget ix. And then y component is positive. So magnitude of this vector is the same. It is k q1 q naught divided by a squared plus h squared divided by r squared times, now I need to multiply by sine theta. Sine theta. And I don't forget iy. So what is cosine theta and sine theta? Let's find out. Sine theta is equal, sine theta is equal, which triangle will I use? Let's use this triangle to find sine theta. What is sine theta? It is opposite leg, which is h, and I divided by hypotenuse. This is sine theta. So it is opposite leg h, and I divided by hypotenuse, which is square root of a squared plus h squared. What is cosine theta? Cosine theta, I use the same triangle, is a, and I divided by square root of a squared plus h squared. So now we bring sine and cosine right here. What we will have? We will have, you know what, I will factor out k. Can I factor out also q1, q naught? Oh, let's keep them there. I'll just factor out k. So I have q1, q naught. Then I have cosine theta, which brings me a in denominator, or in numerator, I'm sorry, in numerator. And then a squared plus h squared, this guy, and another guy, a squared plus h squared square root. 1 plus 1/2 brings me to 3/2. I'm right here, so this is ix. And then plus k. K I already factor out. We erase it. It's already here. So it is q1 q naught divided by a squared plus h squared. and then sine theta brings me h here, and then square root a squared plus h squared brings me to 3/2. And of course, we cannot forget iy here. So this is my vector f1, force F1. We found it. Now we need to find F2. So for F2, I will continue right here, this line. So what will be F2? Well, I have F2x. Let's look at F2. I project it on x. So I will draw a line perpendicular to x. I will use this triangle. And we understand that this angle theta is the same as this. So this is also theta. And this distance between these two charges is the same as this r, because this is a, this is a, this is h. So they are equal to each other. This r squared is also a squared plus h squared. Since angles are the same, r is the same, it's easy for us to write F2. So what is F2x? First question, positive or negative? It will be along negative direction of x. So projection of F2 on x will be negative. I put minus. Minus k, and then product of the charges q2, q naught, q2, q naught, divided by distance between them squared, which is a squared plus h squared. I need to multiply by cosine theta to get x component. So we already know what is cosine theta. It will add me a in numerator. It will give me a in numerator. And then here I will have 3/2. So I put ix. This is my x component of F2. What is y component of F2? Positive or negative? Y component of F2 is positive, so it is plus k. And then it is q2, q naught, q2, q naught, divided by distance squared, a squared plus h squared. This is y component of F2. I need to multiply by sine theta. Sine theta is h divided a squared plus h squared 3/2. And we do not forget iy. So now we know both F1 and F2. All we need to do, we need to add x components and y components together. So let's do it. If you don't mind, I will erase this line, and we will use it to add x and y components together. You don't need to wait for me, just write it down, and we'll check your answer in a minute. F1x, where is f? This is my F1. F1. F1x is right here. So I have k, q1, q naught, a divided by a squared plus h squared 3/2. This is my x component of F1. I need to add x component of F2, which is right here. X component of F2 is right here. It is negative. So I put minus k, q2, q naught, a divided by a squared plus h squared to 3/2. And this will be my ix. It will be x component of the resultant. And now I need to add y components together. So it will be plus. I have y component of F1 right here. So I will have q1, q naught, and I forgot k. So it is k, q1, q naught, h divided by a squared plus h squared to 3/2. and then I add F2y, which is right here. It is plus k Q2 Q naught H divided by a squared plus h squared to 3/2. And this is IY. Y component of the resultant. This is our final answer for FQ naught. And now let's assume that Q1 is equal to Q2. What will happen? Q1 is equal to Q2. If Q1 is equal to Q2, then the length of these two vectors are equal to each other. So magnitudes will be the same. Let's put it equal to Q. So what will happen? Then the magnitude of force will be just Q naught and Q naught here. And x components will cancel each other. Actually, I will redraw it because now we understand that the length of these two vectors will be equal to each other. This is, let me erase components and I will leave just the vectors. So this is one vector, this is F1, this is F2. Q1 is equal to Q2 and is equal to Q now. Do you see that x components cancel each other? So x component of these two vectors will cancel each other. And what we will have just y components. And if you look at our formula, you will immediately see that. So what I have here is Q naught now, Q naught. These two guys cancel each other. And all we have is y components. So from the very beginning, we can write that from symmetry, Fx, net x component, will be 0. And all we have is, for Fq naught, we will have just twice y component. Why twice? I can find just one, and then I multiply it by 2. So it will be 2k Q naught h divided by a squared plus h squared to 3/2. And this will be y component. I don't forget to add IY. So the problem will be much easier, and from the very beginning, without writing x components, we just write from symmetry Fx is 0, and we find just y component created, y component of force F1 or F2, and we multiply it by 2. We found the resultant. Now imagine that Q1 is equal to Q2 still, but it is equal to minus Q. What will happen? Q1 now is equal to Q2 again, but now they both are negative. What will happen then? Now I need to redraw the picture. So I will have Q1 and Q2 negative. This is y. This is minus Q now. This is still Q naught. What will be the forces exerted on Q naught? The force will be attractive force now. We still call this one F1, and this will be F2. Now force F1 and F2 will be attractive forces. Again, from symmetry, we realize that x components will cancel each other. They will have the same magnitude, but opposite direction. So x components will cancel each other. All we need to find is just y component of the resultant. We can find y component of one of these forces, either F1 or F2, and multiply it by 2. What will be the difference? Now it will be in negative y direction. So if I have Q1 equal to Q2 and equal to minus Q now. Minus Q now. What will be the difference in my final answer? I will have y component of resultant negative. So I have to put minus iy here, or I can factor this minus here and put it in front of 2. It will be the same answer. So let's say that Q is minus 3 times 10 to minus 7 coulombs. Q naught is 1.5 times 10 to minus 7 coulombs. And then A, for example, is 5 centimeters. We need to convert it to meters, 0.05 meters. And H is 20 centimeters, or 0.2 meters. And K is constant, which is 9 times 10 to the 9th newtons meters squared over Coulomb squared. This is capital C. Let me put it a little bit better. Okay, and what will be the force? It will be 9 times 10 to the 9th Newton meters squared Coulomb squared. This is K. Minus, I forgot minus, and I forgot 2. So it is minus 2 times this, and then 3 times 10 to minus 7th coulombs, and then 1.5 for Q naught times 10 to minus 7th, then H 0.2 meters, and I divide all this. I need to save some space. 0.2, let it be a little bit thinner. 0.2 meters, and then denominator is a squared, 0.05 meters squared, plus 0.2 meters squared to 3/2. All this is in IY direction. I have minus in front, so I put just IY here. And if I calculate this number, what I will get will be, I will write it in different color. So it will be 0.018 newtons, and it will be in minus IY direction. So we did it.